Thank you, Hector. Last talk. You guys made it. Well, thank you, everybody, for showing up and sticking around for the last talk at TriSwift. This has been a really, really great conference. My first time here. I unfortunately didn't get to go to Tokyo, but this has been an absolute blast. So, like Hector was saying, I'm an engineer here in New York working on Instagram. I was in California for a couple years, and we moved our Instagram infrastructure team, that's our mobile infrastructure team, out to New York just a little bit ago. And since I've been working on infrastructure, we've been doing a lot of really, really cool work. And something that I've been working on for the past year has been rebuilding how our feed works on Instagram. And it's been a really fun process. We've learned a lot. And whenever I go to these sort of conferences, I absolutely love listening to other industry experience talks. If you guys saw the one yesterday about Etsy, I was just like glued, because I think it's fascinating to see how these other companies and organizations work. So I'm here to share a little bit about how we work at Instagram through the lens of this story of rewriting our feed, with maybe a little bit of special something at the end. So, why did we rewrite our feed? Who's heard of technical debt? Who's dealt with technical debt? Yeah, it's like literally every one of us. So Instagram's a 6.5-year-old app. It's pretty old. The code base is still the same. If you go and search through the Git history, if you blame some files, you'll find some Instagram init code commits in there. There's still a couple little pockets of manual memory management. And there's a lot of mess. There were a lot of things that made things really challenging. So for starters, how does the Instagram feed work? Well, we use collection views. And when we're looking at a post on Instagram, we see this big section, and we break it up into all these smaller cells. So this breakdown works something like this. You've got a supplementary view at the top. You've got a cell for the media, cell for all the action items, and then all these text cells at the bottom. What drives this is a data model that we call a feed item. So you have a single feed item that decides how many comments there are, if we're going to show an image, if we're going to play a video, what the user's name is, all of that stuff. When we're dealing with these feed items, our entire app is built around this feed item data model. And it expects this feed item to have an image, to have a video, to have these comments. But what happens when somebody comes along and says, hey, we want to add this new item to the feed. We want to add this new view. You know, it's just a cell. Somebody designed it. Product manager worked on it, says that they want it to work like this. Well, they come to us, the infrastructure team, and we're just like, sorry, can't do it. It's not a feed item. You got an array of users. You don't have any comments. Doesn't make any sense. Well, it sucked. It sucked to tell our teammates no. So how did we get into this place? Well, like I said, we've got this feed item. Instagram launched back in 2010, just images. Over time, we added stuff like video. And then we've got people that come along and want to do stuff adding users, other sort of data models. But I'm sure we've all experienced in software development, we need to make this one little change. Instead of refactor, do what we know is right, we'll just like slap it on, right? Well, that's what we did. And instead of having a video model and these user models, all these extra individual, small, tiny contained models, we had this huge model. And this became really difficult and started to slow us down. Now remember, with this section cell mapping stuff, this is driven by a feed item. And if you're looking at a feed in Instagram, you're not looking at one post, right? You're seeing a bunch. So something needs to take this data model, put it into a section, configure all these cells. Well, that was the responsibility of our view controllers. Notice I said controllers. It's plural. It's not just one. It's 4. We had a view controller that was for our collection view. Inherited from that, we had a view controller that did our networking. Inherited from that, we've got a view controller that does general feeds. And then if you're on the main feed tab of the app, well, we got a view controller for that too. 4 levels deep. So if somebody, like I said, wanted to add this new cell or something, it's tough. Look at how many different levels we have to support this new cell type in. And we were following the principles of MVC. Everybody, what does MVC stand for? Yeah, massive view controller. And we accomplished that one. But in all seriousness, what's the worst that can happen, right? Okay, you've got a little bit of spaghetti code. It's tricky to work in. Maybe it slows you down every once in a while. But is it that bad? Yeah, it could be pretty bad. Technical debt can bite you. Really bad. And we learned our lesson. We're tired of mistakes like this. We don't want this. We don't want articles showing up, waking us up in the middle of the night. We decided we needed to do something. We decided that we needed to get really serious about it. So, we created a new feed. We launched this about 3 months ago, and I want to go through some of the details of this. Our main goals were to fix that view controller inheritance, make the feed way less complicated, and also let people use different cells, different data models. We wanted to get rid of this idea of a feed item. We needed something that was totally agnostic of our data types. So to fix the data problems, we started with diffing. Now, diffing is a concept where you've got an array of stuff. So this is an array of models here, each color representing something different, doesn't matter. And you go to another array, right? So we have another array, same number of items, but you can see some stuff's been deleted, been inserted, moved around. Even the red thing now says cat. So its value is updated. Diffing is super, super helpful when building infrastructure. But to get it right with collection view is pretty tough. First off, you have to delete things in the old array. Then you reload. Then you move anything into its final position. And then you do your inserts based on the final index. Now, to do it well, it takes a little bit of math. Most naive implementations of diffing are usually going to be in complexity n squared. It's exponential time. And when you're doing that many operations, it can be slow. Most implementations I've seen will just go to a background queue, do the math, come back to the foreground, and carry on. But even that is kind of slow, right? You've got a lower priority queue solving a harder problem. Why not just do it on the main thread? Well, we went searching, and we found a paper written in 1978 by a guy named Paul Heckel. And what this paper did was solve this problem in linear time using something called the least common subsequence. And by doing this, we created an algorithm that will find all the deletes, reloads, inserts, and moves between two sets of data and do it in linear time. That let us do it on the main queue. So we could perform all of these updates on the collection view without having to go to the background, without having to do anything too fancy. It's just a much simpler model for us. And on top of that, we figured out how collection view works, which takes a lot longer than you would think. So back to this view controller mess. What did we do? Well, we just got rid of all this stuff. Put it into shared objects, systems, libraries, whatever. They don't need to be view controllers. Networking is networking. Main feed stuff like analytics and all that can be in just an object. But we still had to deal with this. We still had to deal with the feed. Now, this is a concept that we call the world. where this view controller knows about the array of items, how those items get into sections, how those sections are configured, how the cells populate. It deals with interaction, deals with logging, display events, all of this stuff. It's a lot of stuff. So in this new infrastructure that we created, we decided to split things up a bit. We created an abstraction called an item controller. And it's not a fancy name because it's not fancy. It's literally just a little view controller, a view controller for a section. This is where you decide the number of items, you configure your cells, return your cell size, deal with interaction. But most importantly, it's where you store all your business logic. And it's nothing fancy, it's just a collection view. But when we split things up this way, it lets us add any other type of object to our collection views. All you have to do is just create a new item controller, and it handles it for you. So remember when I said that this was impossible? Well, we figured it out. And the team was happy, and we shipped this along with our new infrastructure. So, all that is cool. But after we built this, we asked ourselves, we solved a lot of really complicated problems. What can we actually give back to the community? Some of the complicated problems, like I mentioned with collection view, if you're going to build a new collection view feed, what do you got to do? Subclass view controller, hook it up to the data source, register your cells, sections, items, return some cells, return their size, and then you're going to do batch updates, right? You're like, nah, just have to insert a couple cells at the top, it'll be fine. Then your product manager comes in and is like, hey, but can you delete that one? And you're like, okay, it's just that one. Then you've got reordering. Oh my God. I'm going to try to move. But if you're like me, screw it, I'm just going to reload data. I knew I wouldn't be alone there. So we asked ourselves, we solved this problem. We made this easy. What can we give back? And I'm pretty excited about this because this is one of the first times, excuse me, this isn't one of the first times, this is the first time I have talked about this publicly. We are open sourcing a brand new framework that does all of this for you called IGListKit. Now, like Hector mentioned, I've barely written any Swift. This whole thing is written in Objective-C and C++. So what the hell am I doing here telling you guys that I'm writing this new framework? All of our sample apps and documentation are written 100% in Swift using Objective-C nullability, annotations, and generics. So this thing is 100% Swift compatible. All the C++ is buried so far away you'll never have to see it. All right, let's look at how this works. So one of the most important classes in this framework is called IG item controller. This is that item controller concept that we talked about at the beginning. This is what it looks like. See, Swift? That's a whole item controller. Now don't look too closely, we're going to drill in a little closer, but I wanted to show you that it's not a whole lot of code. All of this is doing is a single cell that has a text label. That's it. So, to actually use this, we create an item controller and we conform to this item type protocol. And that protocol, at compile time, is going to make sure you implement all the important methods, like returning the number of items. So here we have one. In Instagram's main feed, we have a dynamic array for the image, the comments, and the action bar. You return the size. Notice, too, that we have a context object. Ignore the force unwrapping there. I know, I'm sorry. So this cell is the width of the screen, or the width of its container, and 55 points high. Next, this is a new concept, different from collection view. We have this did update to item. This is where the infrastructure is going to hand your item controller the model. Remember back with the mapping, we had all of these models that were mapped to item controllers. In this case, we've got an item we optionally cast it as a string and we store it in an instance variable. Then we take that instance variable, and in our cell for item at index, we dequeue the cell, we set the text on the label, and we return it, just the same as collection view's data source. Two things I want to point out. We've gotten rid of the concept of reuse identifiers, and we've completely eliminated the need to register cells and supplementary views. So that's it. That's an item controller. But what good is an item controller without some infrastructure, without something to use it? We have an IGList adapter. This is what's going to take your data, all of your item controllers, your collection view, put it all together, make it work. To actually use this, you just have to connect the data source. And this is basically it, 2 methods. There's a third, but it doesn't matter here. In the first method, we're just returning an array of stuff. Here, they're all strings. They could be anything. Notice that the return type is this IGList diffable. We've provided default implementations for this protocol, so everything works out of the box. But you can override and extend that protocol to do whatever you want for even smarter diffing. Now, there's another method that for any given item, we return an item controller. So here, we're just returning that same label item controller that we looked at previously. And what does that look like? Woo. Kind of cool. Yeah, thanks for that round of applause. No, this sucks. It's boring. What else can we do? Say we want to add a spinner. Say there's a part of this feed that's still loading. We're waiting on a network request to come in. Well, we can create a token object. Here's just an NS object called spin token, and we can throw it right in the middle of that array. It's just a protocol, so we can put any sort of model objects we want in this. Then, when the infrastructure is asking us for that item controller, we check, is that item that spin token? If it is, we return this new spinner item controller. Otherwise, just fall back to the labels. So what's that look like? Spinner, right in between our cells, right? Nah. It's fine. It's not that exciting. What I think is exciting is that diffing stuff I was talking about. So imagine we've got a UI search bar. As the user is typing and changing the text, we want to actually update these results. So here, in the search bar delegate method, we're going to store the string in an instance variable and call this method perform updates animated. What this is going to do is tell the infrastructure, get those new items, diff them, and update the collection view. What we can do, using some fancy Swift that I learned, is filter our array. So we take our array of strings, we filter them for our actual string here, and we just return it. And this is in the data source method, because this is only going to be called when you tell the infrastructure to update. But what does this actually look like? If I were to start typing in this text field, everything updates. This is performing inserts, deletes, moves, everything on the collection view. I didn't write a single line of code for that collection view. I just configured my cells, my item controllers, and I told my adapter to update. And I get all these animations and updates out of the box. Yeah, now you can clap. So this is cool, but why should I use it, right? I've got a simple app. I've got a table view I call reload data. Does this matter? Well, I think you should use it if you've got multiple data types in this feed. If your feed is getting complicated, if you're tired of dealing with integer enums for your sections, like I am, this is for you. If you want a fast and crash-free feed that has animated updates, this will work really well. It also encourages you to write reusable components from your cells to your item controllers and your view controllers. An item controller written there with these labels and spinners and stuff Well, I could drop that in any other view controller or setup in my app that I wanted to, because they're agnostic of their containers. Lastly, the thing I love is screw these methods. I never want to call perform batch updates or reload data again in my life. Now, you might also be asking yourself, well, Instagram built this. Should I use it? How are they using it? Well, since I started talking, we've performed 3.9 million diffs in the world in the past, 15 minutes, with no crashes, all in the main thread, crazy fast. And I skipped a slide. There are a ton of other features that I have absolutely no time to cover. Stuff like supplementary views, some stock item controllers, all of the custom display events that we've added, and unit tests. That's a feature. And we've been using this extensively. So I mentioned that this entire project started because we wanted to rewrite our main feed. Well, not only did we rewrite our main feed, our Explorer page with all those grid items, IGListKit. Our activity feed, IGListKit. Even these complex cells and interactions in our direct messaging product are using IGListKit. And then lastly, Instagram Stories that we launched about a month ago. That little tray and these full screen items are 100% built in IGListKit. So we are fully committed to using this framework. It is the future of our app. And like I said, we're open sourcing it. We're in the process right now of finishing everything up, and it's going to be on GitHub later this month. So I'm super excited that we got a chance to announce this. I hope that in sharing some of the story about how we work at Instagram, both in California and here in New York, that you've learned something, that you'll be able to take away something and apply it to the apps that you're working on in your organizations. And I really am excited to see what you're able to build with IGListKit. Thank you.